If we could bring the mammoth back tomorrow, would it truly be a mammoth, or just a new animal that looks like one? Every animal alive on Earth today has one thing in common: they are not extinct yet. That sounds simple, but it is far stranger than it seems, because more than 99% of all species that have ever lived on this planet no longer exist. They walked the earth, they hunted, they raised their young, they fought to survive, and then one day, they disappeared, as if they had never existed at all. They vanished, as if they had never existed at all. And the strangest part is this: some were not wiped out by asteroids, some were not destroyed by volcanoes, some did not die in an ice age. Instead, they encountered a single species: humans. Humans are not the strongest predators on Earth, not the fastest, not the largest. Yet no other species in history has changed the fate of so many others. Animals that once numbered in the millions disappeared within a few decades. Some were so common that people believed they could never go extinct. Today, only photographs remain. For some, not even a single video exists, because by the time cameras were invented, they were already gone. In this video, we are not just exploring extinct animals. We are exploring the species that erased them from history. And perhaps the most important question of all: if these animals could speak, what would they say about humanity? The deadliest creature in history is not a lion. It is not a shark. It is not even a dinosaur. The deadliest creature in history is the species watching this video right now. What if a mammoth were born tomorrow? Would it truly be a mammoth, or simply a new creature that looks like one? Can humans really bring back an animal that vanished thousands of years ago? And if we can, what comes next? The dodo, the saber-toothed tiger, perhaps even dinosaurs. But do humans have the right to bring extinct species back? Or are we trying to open a door that nature was never meant to reopen? For a long time, these questions belonged only to science fiction. Mammoths were part of the past. Dodos existed only in history books. Extinct animals were gone forever. Or so we thought. Today, that idea is beginning to change. In laboratories around the world, scientists are studying the DNA of creatures that disappeared thousands of years ago. Some believe that within our lifetime, mammoths could walk the earth again. Others warn that this may be one of the most dangerous experiments humanity has ever attempted, because this is about more than bringing back an animal. The real question is this: should humans have the power to reverse extinction? In this video, we will explore how mammoths disappeared, how scientists are trying to bring them back, and how this technology could change the future of life on Earth. Whether scientists succeed or not, one fact remains unchanged. For thousands of species, there will be no second chance, no laboratory, no rescue mission, no way back. They once ruled forests, oceans, grasslands, and frozen wildernesses. Some survived for millions of years, yet today they exist only in fossils, drawings, and fading memories. These are the animals that disappeared from our world, and their stories are more fascinating than most people realize. Let's begin with one of the most famous extinct animals in history. Today, more than 8 million species are estimated to live on Earth, but that number represents only a tiny fraction of all the creatures that have ever existed. Scientists estimate that over 99% of all species that once lived on our planet are now extinct, gone forever. Some disappeared after ruling the Earth for millions of years. Others vanished within only a few thousand years. But how does a species become extinct? The extinction of an animal is far more complex than simply the death of the last individual. It is the end of an evolutionary journey that may have taken millions of years. When a species disappears, its unique genetics, behaviors, survival strategies, and ecological role disappear with it. Nature never becomes exactly the same again. Throughout Earth's history, there have been several mass extinction events. Around 444 million years ago, the Ordovician extinction wiped out a vast number of marine species. Millions of years later, another extinction event struck during the Devonian period, but the greatest catastrophe occurred approximately 252 million years ago. Scientists call it the Great Dying. During this event, nearly 96% of marine species and around 70% of terrestrial vertebrates disappeared. Life on Earth was pushed to the brink of collapse. Entire ecosystems vanished. The planet had to rebuild itself almost from scratch. Then came the age of the dinosaurs. For roughly 165 million years, dinosaurs dominated the Earth. To put that into perspective, modern humans have existed for only a few 100,000 years. Dinosaurs survived volcanic eruptions, climate shifts, and countless environmental changes. Yet even they could not survive what happened 66 million years ago. A giant asteroid, estimated to be about 10 kilometers wide, slammed into what is now Mexico. The impact released more energy than billions of nuclear bombs. Massive fires erupted across continents. Dust and debris filled the atmosphere. Sunlight was blocked for months or even years. Plants began to die. Herbivores lost their food source. Predators soon followed. The food chain collapsed. The reign of the dinosaurs came to an end. However, extinction is not always caused by sudden disasters. Sometimes it happens slowly. A climate begins to change. Rainfall decreases, rivers dry up, forests shrink, food becomes scarce. Generation after generation, a species struggles to adapt. Its population declines. Its genetic diversity decreases. Diseases become more dangerous. Reproduction becomes more difficult. Eventually, the species reaches a point from which recovery is nearly impossible. Competition is another powerful force. Nature is a constant struggle for survival. Species compete for food, territory, water, and mates. Those that adapt more effectively survive. Those that cannot may gradually disappear. But over the last several thousand years, a new force has emerged. A force unlike any other in Earth's history: humans. For the first time, a single species gained the ability to reshape entire ecosystems. Humans clear forests, build cities, redirect rivers, alter climates, and hunt animals on a massive scale. As human populations expanded, many species found themselves unable to survive the changes. The woolly mammoth is one example. For hundreds of thousands of years, mammoths thrived across vast regions of the northern hemisphere. Then the climate warmed. Grasslands changed. At the same time, humans spread into mammoth territory. Many scientists believe that the combination of environmental change and human hunting ultimately drove mammoths to extinction. The story of the dodo is even more dramatic. For thousands of years, this flightless bird lived safely on an isolated island with no natural predators. Then humans arrived. Along with them came rats, pigs, and other invasive animals. Within only a few decades, the dodo disappeared forever. The Tasmanian tiger, the great auk, the Caribbean monk seal, the moa birds of New Zealand. These are only a few examples from a very long list. Today, many scientists believe that Earth is entering a sixth mass extinction event. Unlike the previous five, this one is not being driven by asteroids or supervolcanoes. It is being driven largely by human activity: habitat destruction, pollution, climate change, overhunting, illegal wildlife trade, invasive species. All of these factors are accelerating extinction rates far beyond natural levels. Thousands of species are currently at risk. Some survive in populations of only a few hundred individuals. Others may disappear before scientists even discover them. Every extinction leaves a gap in nature. A predator disappears. Its prey population explodes. A pollinator vanishes. Plants struggle to reproduce. An ecosystem loses balance. The consequences often spread far beyond a single species. The world before extinction, long before humans built cities, roads, farms, and nations, Earth belonged entirely to nature. There were no fences, no borders, no artificial lights, no engines, no factories, no human voices. Only wind, water, storms, and the sounds of countless wild creatures. Millions of years ago, animals lived in a world that looked completely different from the one we know today. Entire continents were covered by endless forests. Gigantic ferns stretched across the landscape. Massive rivers carved their way through untouched wilderness. The oceans were filled with creatures stranger than anything alive today. Some animals grew to enormous sizes because conditions allowed them to thrive. Food was abundant. Predators were fewer. Competition was different. In many ecosystems, evolution favored size. That is why prehistoric Earth was home to giant insects, enormous reptiles, and mammals that dwarfed many modern animals. Life was harsh. Every day was a struggle for survival. A young animal could spend its entire life avoiding predators. A predator could spend days searching for a single successful hunt. Failure often meant death. Unlike modern animals living in protected reserves, prehistoric creatures faced constant pressure from nature itself. Droughts, floods, volcanic eruptions, ice ages, disease, starvation. Yet despite these dangers, life flourished. Animals developed incredible adaptations. Some evolved powerful armor, others evolved speed. Some relied on camouflage. Others developed intelligence and complex social behavior. One of the most important survival strategies was migration. Long before humans mapped the world, animals were already traveling thousands of kilometers. Ancient herds followed seasonal rains across vast plains. Marine animals crossed entire oceans. Birds navigated enormous distances using stars, magnetic fields, and environmental cues. Migration allowed species to survive changing climates and shifting food sources. Social behavior also became a powerful evolutionary advantage. Many ancient mammals lived in groups. Working together increased survival chances. A herd could detect predators more easily. A pack could hunt larger prey. Parents could better protect their offspring. These strategies are still visible in modern wolves, elephants, lions, and many other species. But prehistoric ecosystems were often far more complex than those of today. Many ancient animals occupied ecological roles that no longer exist. Some species acted as ecosystem engineers. By feeding, digging, trampling vegetation, or dispersing seeds, they shaped entire environments. Without realizing it, these animals influenced the survival of countless other species. The woolly mammoth is a famous example. Scientists believe mammoths helped maintain vast grassland ecosystems by knocking down trees, spreading nutrients, and preventing forests from expanding. When mammoths disappeared, entire landscapes began to change. The same pattern occurred again and again throughout Earth's history. When a major species vanished, the environment often changed with it. This reveals an important truth. Animals do not merely live within ecosystems, they help create them. Ancient life was also shaped by dramatic climate cycles. For millions of years, Earth repeatedly shifted between warmer and colder periods. Glaciers advanced, sea levels rose and fell, habitats expanded and contracted. Species were constantly forced to adapt. Those that adapted survived. Those that could not often disappeared. This process helped drive evolution itself. Every major challenge became a test. Every environmental change became an opportunity for new species to emerge. The world before extinction was not peaceful. It was not stable. It was a constantly changing battlefield of survival. Yet it was also a world of astonishing biodiversity, a world where giant mammals walked across frozen tundras, where enormous birds ruled isolated islands, where giant reptiles dominated rivers and swamps, where creatures unlike anything alive today thrived for millions of years. Most of them are gone now. Only fragments remain, bones buried beneath the ground, footprints preserved in ancient rock, fossils hidden within mountains and deserts. These remnants are all that remain of entire worlds that vanished long before humans appeared. And yet, by studying them, scientists can reconstruct ancient ecosystems and reveal how animals once lived, hunted, migrated, reproduced, and survived. Their story is not just the story of extinction, it is the story of life itself, a story that began hundreds of millions of years before humanity ever existed. To understand why animals become extinct, we must first understand how species survive. Every species exists within a delicate balance of biology, genetics, environment, and competition. As long as that balance remains stable, populations can survive for thousands or even millions of years. But when that balance is disrupted, extinction becomes a possibility. Scientists often describe extinction as the final stage of population decline. It does not happen overnight. In most cases, extinction begins long before the last individual dies. The first warning sign is usually a reduction in population size. When a population becomes smaller, another problem emerges. Genetic diversity begins to decline. Genetic diversity is one of the most important factors in a species' survival. Within every population, individuals carry slightly different genes. These differences help species adapt to diseases, climate changes, predators, and environmental challenges. When populations become too small, genetic variation decreases. As a result, individuals become more genetically similar. This increases the likelihood of inherited diseases and genetic defects. Scientists call this process inbreeding depression. Over time, reproduction becomes less successful. Survival rates decline. The population becomes weaker and more vulnerable. This creates a dangerous cycle. Smaller populations lead to lower genetic diversity. Lower genetic diversity leads to lower survival. Lower survival creates even smaller populations. Eventually, extinction becomes increasingly difficult to prevent. Another important factor is habitat loss. Every species occupies a specific ecological niche. A niche includes food sources, shelter, climate conditions, and interactions with other species. When habitats disappear, species lose the resources necessary for survival. For example, tropical rainforests contain some of the highest levels of biodiversity on Earth. Yet these forests are disappearing rapidly due to logging, agriculture, and urban expansion. As forests shrink, countless species lose their homes. Some adapt, many do not. Climate change creates additional challenges. Animals evolved under specific environmental conditions. Many species require precise temperature ranges, rainfall patterns, or seasonal cycles. Even small changes can have significant consequences. A change of only a few degrees may alter migration routes, breeding seasons, or food availability. In polar regions, warming temperatures reduce sea ice. For species that depend on ice for hunting and reproduction, survival becomes increasingly difficult. Scientists also study trophic cascades. These occur when the disappearance of one species affects many others. Predators are particularly important. When apex predators disappear, prey populations often increase dramatically. This can lead to overgrazing, habitat degradation, and ecosystem instability. One famous example occurred in Yellowstone National Park. When wolves disappeared, elk populations expanded, vegetation suffered, river systems even began to change. When wolves were reintroduced, ecological balance gradually returned. This demonstrates how a single species can influence an entire ecosystem. Scientists refer to such organisms as keystone species. A keystone species has an impact far greater than its population size would suggest. Removing a keystone species can trigger widespread ecological changes. Modern extinction rates concern scientists because they appear to be significantly higher than natural background rates. Background extinction refers to the normal rate at which species disappear over geological time. Today, many researchers estimate extinction rates may be tens to hundreds of times higher than historical averages. This is why some scientists describe the present period as the sixth mass extinction. Unlike previous mass extinctions caused by natural catastrophes, this one is strongly associated with human activities, habitat destruction, pollution, overhunting, climate change, invasive species, illegal wildlife trade. Together, these pressures affect ecosystems across the planet, yet extinction is not inevitable. Conservation biology has demonstrated that species can recover when appropriate actions are taken. Protected habitats, captive breeding programs, wildlife corridors, anti-poaching efforts, scientific monitoring, all have contributed to saving species once thought to be near extinction. The science of extinction teaches us an important lesson. Every species represents millions of years of evolution. Every animal alive today is the result of countless generations that survived impossible challenges. When a species disappears, an entire evolutionary story comes to an end. And once that story ends, it can never truly be written again. To understand why animals become extinct, we must first understand how species survive. Every species exists within a delicate balance of biology, genetics, environment, and competition. As long as that balance remains stable, populations can survive for thousands or even millions of years. But when that balance is disrupted, extinction becomes a possibility. Scientists often describe extinction as the final stage of population decline. It does not happen overnight. In most cases, extinction begins long before the last individual dies. The first warning sign is usually a reduction in population size. When a population becomes smaller, another problem emerges. Genetic diversity begins to decline. Genetic diversity is one of the most important factors in a species' survival. Within every population, individuals carry slightly different genes. These differences help species adapt to diseases, climate changes, predators, and environmental challenges. When populations become too small, genetic variation decreases. As a result, individuals become more genetically similar. This increases the likelihood of inherited diseases and genetic defects. Scientists call this process inbreeding depression. Over time, reproduction becomes less successful. Survival rates decline. The population becomes weaker and more vulnerable. This creates a dangerous cycle. Smaller populations lead to lower genetic diversity. Lower genetic diversity leads to lower survival. Lower survival creates even smaller populations. Eventually, extinction becomes increasingly difficult to prevent. Another important factor is habitat loss. Every species occupies a specific ecological niche. A niche includes food sources, shelter, climate conditions, and interactions with other species. When habitats disappear, species lose the resources necessary for survival. For example, tropical rainforests contain some of the highest levels of biodiversity on Earth. Yet these forests are disappearing rapidly due to logging, agriculture, and urban expansion. As forests shrink, countless species lose their homes. Some adapt, many do not. Climate change creates additional challenges. Animals evolved under specific environmental conditions. Many species require precise temperature ranges, rainfall patterns, or seasonal cycles. Even small changes can have significant consequences. A change of only a few degrees may alter migration routes, breeding seasons, or food availability. In polar regions, warming temperatures reduce sea ice. For species that depend on ice for hunting and reproduction, survival becomes increasingly difficult. Scientists also study trophic cascades. These occur when the disappearance of one species affects many others. Predators are particularly important. When apex predators disappear, prey populations often increase dramatically. This can lead to overgrazing, habitat degradation, and ecosystem instability. One famous example occurred in Yellowstone National Park. When wolves disappeared, elk populations expanded, vegetation suffered, river systems even began to change. When wolves were reintroduced, ecological balance gradually returned. This demonstrates how a single species can influence an entire ecosystem. Scientists refer to such organisms as keystone species. A keystone species has an impact far greater than its population size would suggest. Removing a keystone species can trigger widespread ecological changes. Modern extinction rates concern scientists because they appear to be significantly higher than natural background rates. Background extinction refers to the normal rate at which species disappear over geological time. Today, many researchers estimate extinction rates may be tens to hundreds of times higher than historical averages. This is why some scientists describe the present period as the sixth mass extinction. Unlike previous mass extinctions caused by natural catastrophes, this one is strongly associated with human activities, habitat destruction, pollution, overhunting, climate change, invasive species, illegal wildlife trade. Together, these pressures affect ecosystems across the planet, yet extinction is not inevitable. Conservation biology has demonstrated that species can recover when appropriate actions are taken. Protected habitats, captive breeding programs, wildlife corridors, anti-poaching efforts, scientific monitoring, all have contributed to saving species once thought to be near extinction. The science of extinction teaches us an important lesson. Every species represents millions of years of evolution. Every animal alive today is the result of countless generations that survived impossible challenges. When a species disappears, an entire evolutionary story comes to an end. And once that story ends, it can never truly be written again. Before we explore their stories in detail, let's briefly meet some of the most famous extinct animals that once walked, flew, or swam across our planet. Each of these creatures played a unique role in Earth's history. Some disappeared thousands of years ago, others vanished only a few centuries ago. And while their species are gone forever, their stories continue to fascinate scientists and animal lovers around the world. In a moment, we'll take a closer look at how they lived, hunted, survived, and ultimately disappeared. But first, let's meet them. The most famous extinct animals. 1. Woolly mammoth. One of the most famous extinct animals in history. Woolly mammoths lived during the Ice Age and were close relatives of modern elephants. Covered in thick fur and equipped with long, curved tusks, they were perfectly adapted to cold environments. Most mammoths disappeared around 4,000 years ago due to climate change and human hunting. 2. Dodo, the symbol of extinction. The dodo was a flightless bird that lived only on Mauritius Island in the Indian Ocean. Having evolved without natural predators, it showed little fear of humans. After people arrived on the island in the 1600s, the species became extinct within a few decades. 3. Tasmanian tiger, thylacine. The predator that looked like a wolf and a tiger at the same time. Native to Australia and Tasmania, the thylacine was a marsupial predator. Farmers hunted it extensively because they believed it attacked livestock. The last known individual died in captivity in 1936. 4. Saber-toothed cat. one of the most terrifying predators of the Ice Age. Known for its enormous canine teeth, this predator hunted large mammals across North and South America. Despite its fearsome appearance, scientists believe it relied on ambush attacks rather than speed. 5. Great auk, the penguin of the North Atlantic. This large, flightless bird lived around Iceland, Greenland, and Canada. It was heavily hunted for food, feathers, and oil. The last confirmed pair was killed in 1844. 6. Quagga half-zebra, half-horse in appearance. The quagga was a subspecies of zebra that lived in South Africa. Its front body had zebra-like stripes, while the rear part resembled a horse. Excessive hunting drove it to extinction in the late 19th century. 7. Steller's sea cow, a giant relative of the manatee. Discovered in 1741, this enormous marine mammal could grow over 8 meters long and weigh several tons. Humans hunted it so heavily that it became extinct only 27 years after its discovery. 8. Moa, the giant bird of New Zealand. Some moa species reached over 3.5 meters in height, making them among the tallest birds ever known. They had no wings at all. Human hunting caused their extinction roughly 600 years ago. 9. Irish elk, one of the largest deer ever to exist. Its antlers could span more than 3.5 meters from tip to tip. These impressive animals roamed Europe and Asia during the Ice Age, before disappearing around 7,700 years ago. 10. Passenger pigeon, a bird so numerous that it darkened the sky. Billions once lived across North America. Flocks could stretch for hundreds of kilometers. However, intensive hunting and habitat destruction caused one of the fastest population collapses ever recorded. The last passenger pigeon died in 1914. 11. Smilodon, the most famous saber-toothed predator. Often mistakenly called a tiger, Smilodon was not closely related to modern tigers. It possessed powerful forelimbs and massive canine teeth used to bring down large prey. 12. Megalodon, the largest shark that ever lived. This gigantic predator ruled the oceans millions of years ago. Scientists estimate it reached lengths of up to 20 meters. Its bite force may have been one of the strongest in vertebrate history. 13. Woolly rhinoceros, the mammoth's Ice Age companion. Covered with thick fur, it lived across Europe and northern Asia. Climate change and hunting likely contributed to its extinction around 10,000 years ago. 14. American lion, the largest cat in North American history. Larger than modern African lions, it lived during the last Ice Age and hunted giant herbivores across the continent. 15. Tyrannosaurus rex, the king of the dinosaurs. Although it disappeared 66 million years ago, T-Rex remains one of the most recognizable animals ever discovered. It stood at the top of the food chain in late Cretaceous ecosystems and possessed one of the most powerful bites in the animal kingdom. Woolly mammoth. Imagine standing on a frozen plain 20,000 years ago. The wind is howling across an endless landscape of snow and grass. The temperature is far below freezing. There are no cities, no roads, no humans as we know them today. Only wilderness. Then, in the distance, something massive begins to move. A dark shape emerges through the blowing snow, then another and another. A giant herd is approaching. Towering over the frozen landscape are creatures covered in thick brown fur, carrying enormous curved tusks that can reach several meters in length. These are woolly mammoths. But what exactly were they? Were they simply giant elephants? Or were they something entirely different? How did animals weighing up to 6 tons survive one of the harshest climates Earth has ever known? How could they find enough food in a world covered by ice? How did newborn mammoths survive temperatures that could kill many modern animals within hours? And perhaps the greatest question of all, if mammoths were so successful, why are they no longer here? For hundreds of thousands of years, woolly mammoths dominated vast regions of Europe, Asia, and North America. They survived ice ages. They survived extreme winters. They survived environmental changes that wiped out countless other species. Yet despite all of this, they eventually disappeared. Why? To understand the mammoth, we must first understand the world it lived in. Contrary to popular belief, the Ice Age was not simply a frozen wasteland. Large areas were actually covered by grasslands known as the Mammoth Steppe. This ecosystem stretched across thousands of kilometers. It was one of the largest ecosystems that ever existed. The mammoth was perfectly adapted to this environment. Its thick fur could exceed 1 meter in length. Beneath that fur was a thick layer of fat that acted as insulation. Its ears were much smaller than those of modern elephants, reducing heat loss. Even its blood may have evolved special adaptations that allowed it to function in extreme cold. Everything about the mammoth was designed for survival, but survival was never easy. A fully grown mammoth had few predators. However, young mammoths were vulnerable. Ancient wolves hunted in packs. Cave lions stalked the grasslands. Even bears could pose a threat. This is one reason mammoths often traveled in herds. Like modern elephants, they likely relied on social bonds for protection. The herd was more than a group. It was a survival system. Older females protected calves. Knowledge was passed from one generation to the next. Migration routes, water sources, seasonal feeding grounds, all of it may have been remembered and shared within the herd. Yet an even greater challenge was approaching. Around 12,000 years ago, Earth's climate began to change dramatically. The last ice age was ending. Temperatures increased. Glaciers retreated. Forests began spreading into areas once dominated by open grasslands. The mammoth's world was disappearing. The vast mammoth steppe that had supported these giants for thousands of years started shrinking. Food became less abundant. Migration patterns became disrupted. Populations became isolated. And then another factor entered the equation: humans. By this time, humans had spread across much of the mammoth's range. Unlike wolves or cave lions, humans possessed intelligence, planning, and weapons. For mammoths, this was a completely new type of predator. Scientists continued to debate exactly how much humans contributed to mammoth extinction. Was climate change the primary cause? Did human hunting finish populations already weakened by environmental change? Or was it a combination of both? The answer remains one of the greatest mysteries in Ice Age science. What we do know is that mammoth populations declined rapidly. Herds became smaller. Habitats became fragmented. Genetic diversity decreased. Eventually, most populations vanished. Yet the story did not end there. Remarkably, some mammoths survived on isolated Arctic islands, long after their mainland relatives disappeared. One population lived on Wrangel Island, north of Siberia. These last mammoths survived until roughly 4,000 years ago. Think about that. While humans were building pyramids in ancient Egypt, small groups of mammoths were still walking across remote Arctic islands. For thousands of years, they had survived everything nature threw at them: ice ages, predators, environmental change. Yet in the end, even giants can fall. Today, mammoths exist only as fossils, frozen remains, and fragments of DNA preserved in Arctic ice. But their story may not be over. Modern scientists are now attempting something once thought impossible. Using genetic technology, researchers hope to recreate mammoth traits in living elephants. Could mammoths one day walk the earth again? Would such an animal truly be a mammoth? See the dodo. What if I told you that one of the most famous extinct animals in history wasn't a terrifying predator, wasn't a giant beast, and wasn't wiped out during some ancient catastrophe? What if its greatest mistake was simply not being afraid? Imagine living on an island for thousands, perhaps millions, of years. No wolves, no lions, no tigers, no humans, no natural predators at all. Would you ever learn to run from danger? Would you even know what danger looks like? This was the world of the dodo, a strange-looking bird that lived on the isolated island of Mauritius in the Indian Ocean. For countless generations, the dodo existed in a paradise unlike almost anywhere else on Earth. Food was plentiful. Predators were almost non-existent. Survival was relatively easy. Over time, evolution shaped the dodo for this peaceful environment. It became larger, heavier, its wings became smaller. Eventually, it lost the ability to fly entirely. Why waste energy on flight when nothing is trying to kill you? From an evolutionary perspective, it made perfect sense. The dodo stood about 1 meter tall and weighed up to 20 kilograms. It had a large hooked beak, strong legs, and a body covered with grayish feathers. To modern eyes, it looked unusual, almost comical. But in its own environment, the dodo was perfectly adapted. For thousands of years, the species thrived. Then everything changed. In the late 1500s, European sailors arrived on Mauritius. For the first time in its history, the dodo encountered humans. And the bird had absolutely no idea what humans were. Imagine seeing a creature that had never evolved a fear response toward people. A bird that did not run away. A bird that allowed humans to approach closely. A bird that had never learned what a predator was. The results were disastrous. Sailors quickly discovered that dodos were easy to catch. Many were killed for food, but surprisingly, direct hunting may not have been the biggest problem. The real threat arrived with humans. Rats, dogs, cats, pigs, monkeys, animals that had never existed on Mauritius before. These invasive species spread across the island. Dodo nests were usually built on the ground. Their eggs suddenly became easy targets. Rats ate eggs, pigs destroyed nests, dogs hunted young birds. Generation after generation, fewer chicks survived. The dodo population began to collapse. What had survived for thousands of years suddenly faced challenges it had never evolved to handle. And evolution could not act fast enough. This is one of the most important lessons in extinction science. Evolution requires time, sometimes thousands of generations. But environmental change can happen almost instantly. The dodo found itself trapped between those two realities. Scientists believe the species disappeared around 1681. Think about that. Only a few decades passed between human arrival and extinction. A species that had survived for countless generations vanished in less than a human lifetime. Today, the dodo has become something much larger than a bird. It has become a symbol of extinction. A reminder of how quickly biodiversity can disappear, a warning about the consequences of human actions. Yet many mysteries remain. What did the dodo truly look like? How intelligent was it? How did it behave in the wild? How many actually lived on Mauritius before humans arrived? Because so few scientific records exist, many questions may never be answered. Ironically, one of the world's most famous extinct animals is also one of the least understood. Today, only bones, drawings, and scientific reconstructions remain, but the story of the dodo continues to fascinate scientists because its extinction teaches an uncomfortable truth. Sometimes a species does not disappear because it is weak. Sometimes it disappears because the world changes faster than it can adapt. And perhaps the most haunting question remains: if humans had never arrived on Mauritius, would dodos still be walking its forests today? The Tasmanian tiger, thylacine. What if I told you that one of the most mysterious extinct predators in modern history may have survived long enough to be photographed, filmed, and even heard? What if this wasn't a creature that vanished thousands of years ago, but one that disappeared only a few generations ago? And what if people are still searching for it today? Meet the Tasmanian tiger. known scientifically as the thylacine, a predator so unusual that even scientists struggled to classify it. Was it a wolf, a dog, a tiger, or something entirely different? At first glance, it looked like a strange mixture of several animals. It had the body of a dog, the striped back of a tiger, the long tail of a kangaroo, and a jaw that could open almost unbelievably wide. But despite its appearance, the Tasmanian tiger was not related to wolves or dogs at all. It was a marsupial, just like kangaroos and koalas. This means females carried their young in a pouch. For millions of years, the thylacine evolved separately from the great predators of other continents. Australia's isolation created a unique evolutionary experiment. Without wolves, big cats, or bears, marsupial predators filled ecological roles that elsewhere belonged to placental mammals. The Tasmanian tiger became one of the most successful. It once lived across mainland Australia, New Guinea, and Tasmania. For thousands of years, it occupied the position of apex predator. It hunted wallabies, small mammals, birds, and other prey. Its striped back likely helped it blend into forests and grasslands. Its powerful jaws allowed it to capture struggling animals. Everything seemed perfectly adapted for survival. So what happened? Why did a predator that survived for millions of years suddenly disappear? The answer begins with human expansion. Thousands of years ago, dingoes arrived in Australia. Scientists believe competition with these wild dogs may have contributed to the disappearance of thylacines from mainland Australia. Eventually, the species survived only on Tasmania. For a time, the island acted as a refuge, a final sanctuary, but then another predator arrived: humans. European settlers reached Tasmania in the early 1800s. Soon, sheep farming expanded across the island. Farmers began accusing the thylacine of killing livestock. Whether these accusations were entirely justified remains debated even today. Some evidence suggests the animal may have been blamed for attacks committed by dogs, but by then, the damage had begun. The government introduced bounty programs. Money was offered for every Tasmanian tiger killed. Thousands were hunted, trapped, shot, poisoned. Year after year, the population declined. As numbers fell, new problems emerged: habitat loss, disease, reduced genetic diversity. The species became increasingly vulnerable, yet warnings were ignored. Scientists were already expressing concern. Some believed extinction was becoming inevitable. Still, hunting continued. Then came one of the saddest moments in conservation history. In 1936, the last known Tasmanian tiger died at the Hobart Zoo. Its name was never officially recorded. Its final hours remain heartbreaking. Locked alone in an enclosure, it reportedly died after being exposed to unusually cold weather. Just months earlier, the species had finally received legal protection. Too late. The last individual was already gone. An entire evolutionary lineage disappeared from Earth. Or did it? For decades, reports continued to emerge. People claimed to see striped animals deep within Tasmania's wilderness. Hunters reported encounters. Campers described strange sounds. Some even claimed to photograph living thylacines. Could any of these reports be true? Or are they simply the result of hope? Scientists remain skeptical. No verified evidence has ever confirmed the survival of the species. Yet the mystery persists. And perhaps that mystery is part of what makes the Tasmanian tiger so fascinating. Unlike mammoths or dinosaurs, the thylacine does not feel ancient. It feels recent, modern, almost within reach. We have photographs of it. We have film footage. We know what it looked like, how it moved, how it behaved. Its extinction happened during an era when humanity already understood the consequences of destroying wildlife. Which raises an uncomfortable question. If we knew extinction was possible, why didn't we stop it? Today, advances in genetics have created another extraordinary possibility. Some scientists are exploring whether extinct species, such as the thylacine, could one day be partially recreated using DNA technology. Could the Tasmanian tiger return? Would it truly be the same animal, or merely a genetic imitation? No one knows, but one thing is certain. The story of the Tasmanian tiger is more than the story of a lost predator. The saber-toothed cat, Smilodon. What if one of the most feared predators in history wasn't a lion, wasn't a tiger, and wasn't even a true big cat? What if it carried weapons so extreme that no predator alive today has anything comparable? Imagine walking across the grasslands of Ice Age America. Mammoths roam in the distance. Giant ground sloths move slowly through the landscape. Ancient bison graze across open plains. Then suddenly, hidden among the shadows, a predator watches. Patient, silent, waiting. Its eyes are fixed on its target, and protruding from its mouth are two enormous curved teeth. Teeth that can grow over 28 centimeters long. This is Smilodon, better known as the saber-toothed cat, one of the most iconic predators that ever lived. But despite its reputation, many people misunderstand this animal. Was it simply an ancient tiger? No. Surprisingly, Smilodon was not closely related to modern tigers. It belonged to a completely different branch of the cat family tree. It evolved its own unique hunting style, its own unique body structure, and one of the strangest weapons ever developed by a mammalian predator. The first thing people notice is the teeth, those giant saber-like canines. But why would evolution create such enormous teeth? What advantage did they provide? Wouldn't they break easily? How could a predator use them without damaging them? For decades, scientists debated these questions. Modern research suggests that Smilodon was not built for long chases. Unlike cheetahs, it wasn't designed for speed. Unlike wolves, it wasn't designed for endurance. Instead, Smilodon was built for power. Its forelimbs were incredibly muscular. Some scientists compare them to those of modern bears. These powerful limbs may have helped it wrestle prey to the ground. Only after immobilizing the victim would it use its famous teeth. Rather than crushing bones, Smilodon likely delivered precise killing bites to soft tissue areas such as the throat. This strategy reduced the risk of breaking its delicate canines. But what exactly was it hunting? The Ice Age was filled with enormous herbivores. Ancient bison, young mammoths, camels, horses, ground sloths. Many of these animals were much larger than prey hunted by most modern predators. Bringing them down required strength, coordination, and patience. Some researchers believe Smilodon may even have hunted cooperatively. Could these predators have lived in social groups similar to lions? The evidence is still debated. However, fossils discovered at California's famous La Brea tar pits provide intriguing clues. Thousands of Smilodon skeletons have been found there. Many show signs of severe injuries that healed during the animal's lifetime. Broken bones, damaged limbs, serious wounds. How did injured animals survive long enough to heal? One possibility is social behavior. If group members shared food or protected injured individuals, survival would have been more likely. Could Smilodon have been more social than we once believed? The mystery remains unsolved. For hundreds of thousands of years, Smilodon thrived across the Americas. It became one of the most successful predators of the Ice Age. Then everything changed. Around 12,000 years ago, many of the giant animals that dominated the Ice Age began disappearing. Mammoths declined. Giant ground sloths vanished. Ancient horses disappeared from North America. Entire ecosystems began collapsing. Without these large herbivores, predators like Smilodon faced a serious problem. Food was becoming scarce. At the same time, another new competitor was spreading rapidly: humans. As human populations expanded, hunting pressure increased. Environmental changes intensified. Many large mammals disappeared. Eventually, Smilodon vanished as well. But which factor was responsible? Climate change, loss of prey, human activity, or all three combined? Scientists continue to debate the answer. What makes Smilodon particularly fascinating is that it represents a completely different solution to predation. Modern predators rely heavily on speed, endurance, pack tactics. Smilodon relied on overwhelming strength and specialized weapons. It evolved for a world filled with giant prey. When that world disappeared, so did one of its most extraordinary hunters. Today, all that remains are fossils. Skeletons buried beneath ancient sediments, bones trapped in tar pits, fragments of a lost ecosystem. Yet even after thousands of years, the image of Smilodon continues to capture our imagination, because when people think of prehistoric predators, they often picture dinosaurs. But for the humans who lived at the end of the Ice Age, the true nightmare may not have been a dinosaur at all. It may have been a silent shadow hidden in the grass, a predator armed with teeth unlike anything the modern world has ever seen. 5. The Great Auk. What if an animal survived countless storms, brutal winters, and thousands of years of natural challenges, only to disappear because humans wanted its feathers? What if one of the most successful seabirds in history was driven to extinction in less than a few centuries? And what if its final moments were witnessed by the very people responsible for its disappearance? Meet the Great Auk, a bird that once dominated the cold waters of the North Atlantic, a bird often called the penguin of the North. But unlike modern penguins, the Great Auk lived in the Northern Hemisphere. It thrived long before humans became a serious threat. Standing nearly 1 meter tall, the Great Auk was a remarkable creature. Its body was perfectly designed for life in the ocean. Its wings were too small for flight, but underwater, those same wings became powerful tools. The Great Auk could dive deep beneath the surface and pursue fish with incredible efficiency. Some scientists believe it could remain underwater for several minutes at a time. In many ways, it occupied the same ecological role that penguins occupy today in the Southern Hemisphere. But how does a bird lose the ability to fly? Why would evolution allow such an important skill to disappear? The answer lies in energy. Flight requires enormous amounts of energy. For the Great Auk, there were very few predators on land. Food existed mainly in the ocean. Over thousands of generations, natural selection favored stronger swimmers rather than stronger flyers. Eventually, flight became unnecessary and then impossible. For thousands of years, this strategy worked perfectly. The species spread across Iceland, Greenland, Canada, Scotland, and other parts of the North Atlantic. Large colonies gathered on isolated, rocky islands. Millions of birds nested together. Generation after generation, century after century, the Great Auk became one of the most successful seabirds on Earth. Then humans arrived. At first, the bird seemed like an endless resource. Sailors captured them for food. Fishermen used them as bait. Their feathers became valuable commodities. Ships often landed on breeding islands and slaughtered hundreds of birds at a time. Sometimes thousands. The birds rarely escaped. Why? Because they couldn't fly. Imagine being a species that evolved in a world where running away was rarely necessary, suddenly facing a predator capable of killing entire colonies in a single day. The Great Auk had no defense against humans. As demand for feathers increased during the 1700s and 1800s, hunting intensified. Pillows and mattresses stuffed with feathers became fashionable. Collectors began searching for rare specimens. Museums wanted preserved birds. The rarer the Great Auk became, the more valuable it was. And the more valuable it became, the more people hunted it. This created a deadly cycle. The closer the species moved toward extinction, the faster extinction arrived. By the early 1800s, only a few colonies remained. Scientists and collectors knew the bird was disappearing, yet instead of protecting it, many rushed to obtain the last specimens. One of the final chapters occurred in Iceland. On June 3, 1844, the last confirmed breeding pair of great auks was found on LD Island. The birds were captured and killed. Their single egg was accidentally crushed. Think about that moment. An entire species, millions of years of evolution, countless generations, all ending on a single rocky island with one broken egg. Today, many historians consider the extinction of the great auk one of the earliest warnings about the dangers of uncontrolled exploitation. Unlike mammoths or dinosaurs, the great auk disappeared during a time when humans could document what was happening. People watched the decline, people recorded it, and yet it happened anyway. Could the species have been saved? Almost certainly. If conservation measures had been introduced earlier, the outcome might have been different, but by the time serious concern emerged, there were simply too few birds left. Today, only skeletons, preserved specimens, paintings, and written accounts remain. Yet the great auk continues to influence modern conservation efforts. Its story helped inspire some of the earliest wildlife protection movements because it revealed an uncomfortable truth. Extinction does not always happen because nature fails. Sometimes extinction happens because humans refuse to stop. And perhaps the most haunting question remains: how many other species are following the same path right now? And will we recognize the warning signs before it is too late? 6. The quagga. What if one of the strangest animals in history looked like it couldn't decide what it wanted to be? Was it a zebra? Was it a horse? Or was it something entirely unique? Imagine traveling across the vast grasslands of South Africa 200 years ago. Large herds move across the horizon. At first glance, they look like zebras. But something seems unusual. The front half of their bodies is covered in bold black and white stripes, yet the stripes gradually disappear toward the back. Their hindquarters look almost identical to those of a horse. This mysterious animal was known as the quagga, one of the most unusual members of the zebra family. For centuries, people were fascinated by its appearance. Even scientists struggled to understand exactly what it was. Was it a separate species, a hybrid, a strange evolutionary accident? Today, we know the answer. The quagga was actually a subspecies of the plains zebra, but during its lifetime, nobody knew that. Its unique appearance made it seem like something completely different. The quagga once roamed the open grasslands of South Africa in large numbers. Like modern zebras, it was a social animal. It lived in herds. It relied on group protection. It spent much of its day grazing on grasses that covered the African plains. Life for the quagga had remained relatively stable for thousands of years. Predators such as lions, hyenas, and leopards hunted them. But these were natural challenges. The quagga had evolved alongside those predators. It knew how to survive them. Then came a threat it had never encountered before: humans. As European settlers expanded across southern Africa, vast areas of land were transformed. Farms spread across the grasslands. Livestock numbers increased. Competition for grazing land intensified. The quagga suddenly found itself competing not only with wild animals, but also with enormous numbers of cattle and sheep. To many settlers, the quagga was viewed as a nuisance, a competitor, an animal taking up valuable grazing resources. And unlike predators, humans carried firearms. Large numbers of quaggas were shot. Some were hunted for meat, others for their hides. Many were killed simply to remove them from grazing areas. Year after year, their numbers declined. At the time, few people realized what was happening. The quagga was so common that extinction seemed impossible. How could an animal seen everywhere suddenly disappear? Yet this is one of the most dangerous assumptions in conservation. People often believe abundant species will always remain abundant. History repeatedly proves otherwise. As hunting continued, quagga populations collapsed. By the late 1800s, they had become extremely rare. Then, in 1883, the final known quagga died at the Artis Zoo in Amsterdam. An entire animal vanished from the earth, and remarkably, nobody even realized it at first. There was no global announcement, no major conservation effort, no emergency rescue plan. The species simply disappeared. Only later did scientists recognize the significance of what had happened. For decades, many mysteries surrounded the quagga. Then, in the 1980s, scientists made a groundbreaking discovery. DNA extracted from preserved quagga remains revealed that it was not a completely separate species. It was a subspecies of the plain zebra. This discovery made the quagga scientifically important for another reason. It became one of the first extinct animals ever studied using ancient DNA. But the story doesn't end there, because the quagga has become part of one of the most unusual conservation projects in the world. Known as the Quagga Project, scientists and breeders have attempted to selectively breed plain zebras that display quagga-like characteristics. Generation after generation, zebras with reduced striping are selected. The goal is to recreate an animal that closely resembles the extinct quagga. But an important question remains. If an animal looks like a quagga, is it truly a quagga? Or is it simply a zebra that resembles one? The debate continues, yet regardless of the answer, the quagga's story remains remarkable. It reminds us that extinction does not always happen in remote prehistoric times. Sometimes it happens recently, quietly, almost unnoticed. And perhaps the most unsettling lesson of all is this. The quagga was once so common that people believed it could never disappear. Today, it exists only in photographs, museum specimens, and history books. A powerful reminder that no species is guaranteed a future. 7. Steller's sea cow. What if a giant marine animal larger than many cars once peacefully floated through the cold waters of the North Pacific? What if it had survived for thousands of years, only to disappear less than 3 decades after humans discovered it? And what if one of the largest mammals of its time was so gentle that it never even tried to escape? Meet Steller's sea cow, one of the most extraordinary and tragic extinction stories in history. The animal was first scientifically described in 1741 by a German naturalist named Georg Wilhelm Steller. When Steller encountered the species, he was astonished. Before him was a marine mammal unlike anything he had ever seen. Massive, slow-moving, completely peaceful, and seemingly unafraid of humans. But what exactly was this creature? Despite its enormous size, Steller's sea cow was actually related to modern manatees and dugongs. These animals belong to a group known as Sirenians. However, Steller's sea cow was far larger than any living relative. Scientists estimate that adults could reach lengths of up to 9 meters and weigh between 8 and 10 tons. That means some individuals were heavier than African elephants. Imagine seeing such a giant moving silently through icy coastal waters. Its body was covered by thick, dark skin. Observers often compared it to tree bark. Unlike whales, it lacked a dorsal fin. Unlike seals, it spent nearly its entire life in shallow coastal waters. Its diet was surprisingly simple. Seaweed, lots of seaweed. Every day, these enormous herbivores consumed massive quantities of kelp and other marine plants. In doing so, they played an important role within coastal ecosystems. Much like elephants shape African landscapes, Steller's sea cows may have helped shape underwater environments. Yet perhaps the most remarkable thing about them was their behavior. Historical accounts suggest they were incredibly calm. They lived in family groups. Parents cared for their young. Individuals often stayed close together. When one animal was injured, others sometimes remained nearby instead of fleeing. This behavior may have strengthened social bonds. Unfortunately, it also made them easy targets, and that would prove disastrous. When Russian explorers reached the region, they quickly realized the value of these animals. Their meat was abundant. Their fat could be used for oil. Their hides could be turned into leather. For sailors spending months at sea, the sea cow represented a floating supply of food and resources. The problem was simple. The species reproduced slowly. Like many large mammals, females likely gave birth infrequently. Population growth was naturally limited. When hunting pressure increased, the animals could not replace their numbers fast enough. Year after year, more were killed. The population began shrinking. And unlike many marine animals, Steller's sea cow had nowhere else to go. Its range was already extremely limited. Scientists believe that by the time Europeans discovered the species, it survived only around the Commander Islands near Russia. It was already vulnerable. Human hunting simply accelerated the inevitable. Then came one of the fastest extinctions ever recorded. The species was discovered in 1741. By 1768, it was gone. Only 27 years later. Think about that. An animal that had survived natural climate changes, storms, predators, and thousands of years of environmental challenges disappeared within a single human generation. Few extinction stories are as rapid. Few are as shocking. Today, scientists continue to study bones and historical records to understand this lost giant. How many existed before humans arrived? Were their populations already declining? Could they have survived if hunting had been controlled? We may never know. But one thing is certain. Steller's sea cow teaches a powerful lesson. Large animals often seem invincible. Their size gives an illusion of strength, an illusion of permanence. Yet history repeatedly shows that even giants can vanish. Not because they are weak, not because they fail to adapt, but because environmental pressures suddenly become greater than their ability to survive. The sea cow's story is not merely about extinction. It is about vulnerability. It is about how quickly an ecosystem can lose one of its most remarkable inhabitants. And it leaves us with an uncomfortable question. If humanity could erase a 10-ton marine giant in less than 30 years, how many other species might disappear before we even realize they are in danger? 7. Steller's sea cow. What if a giant marine animal larger than many cars once peacefully floated through the cold waters of the North Pacific? What if it had survived for thousands of years, only to disappear less than 3 decades after humans discovered it? And what if one of the largest mammals of its time was so gentle that it never even tried to escape? Meet Steller's sea cow, one of the most extraordinary and tragic extinction stories in history. The animal was first scientifically described in 1741 by a German naturalist named Georg Wilhelm Steller. When Steller encountered the species, he was astonished. Before him was a marine mammal unlike anything he had ever seen. Massive, slow-moving, completely peaceful, and seemingly unafraid of humans. But what exactly was this creature? Despite its enormous size, Steller's sea cow was actually related to modern manatees and dugongs. These animals belong to a group known as sirenians. However, Steller's sea cow was far larger than any living relative. Scientists estimate that adults could reach lengths of up to 9 meters and weigh between 8 and 10 tons. That means some individuals were heavier than African elephants. Imagine seeing such a giant moving silently through icy coastal waters. Its body was covered by thick, dark skin. Observers often compared it to tree bark. Unlike whales, it lacked a dorsal fin. Unlike seals, it spent nearly its entire life in shallow coastal waters. Its diet was surprisingly simple. Seaweed, lots of seaweed. Every day, these enormous herbivores consumed massive quantities of kelp and other marine plants. In doing so, they played an important role within coastal ecosystems. Much like elephants shape African landscapes, Steller's sea cows may have helped shape underwater environments. Yet perhaps the most remarkable thing about them was their behavior. Historical accounts suggest they were incredibly calm. They lived in family groups. Parents cared for their young. Individuals often stayed close together. When one animal was injured, others sometimes remained nearby instead of fleeing. This behavior may have strengthened social bonds. Unfortunately, it also made them easy targets, and that would prove disastrous. When Russian explorers reached the region, they quickly realized the value of these animals. Their meat was abundant. Their fat could be used for oil. Their hides could be turned into leather. For sailors spending months at sea, the sea cow represented a floating supply of food and resources. The problem was simple. The species reproduced slowly. Like many large mammals, females likely gave birth infrequently. Population growth was naturally limited. When hunting pressure increased, the animals could not replace their numbers fast enough. Year after year, more were killed. The population began shrinking, and unlike many marine animals, Steller's sea cow had nowhere else to go. Its range was already extremely limited. Scientists believe that by the time Europeans discovered the species, it survived only around the Commander Islands near Russia. It was already vulnerable. Human hunting simply accelerated the inevitable. Then came one of the fastest extinctions ever recorded. The species was discovered in 1741. By 1768, it was gone. Only 27 years later, think about that. An animal that had survived natural climate changes, storms, predators, and thousands of years of environmental challenges disappeared within a single human generation. Few extinction stories are as rapid, few are as shocking. Today, scientists continue to study bones and historical records to understand this lost giant. How many existed before humans arrived? Were their populations already declining? Could they have survived if hunting had been controlled? We may never know, but one thing is certain. Steller's sea cow teaches a powerful lesson. Large animals often seem invincible. Their size gives an illusion of strength, an illusion of permanence. Yet history repeatedly shows that even giants can vanish, not because they are weak, not because they fail to adapt, but because environmental pressures suddenly become greater than their ability to survive. The sea cow's story is not merely about extinction. It is about vulnerability. It is about how quickly an ecosystem can lose one of its most remarkable inhabitants. And it leaves us with an uncomfortable question. If humanity could erase a 10-ton marine giant in less than 30 years, how many other species might disappear before we even realize they are in danger? 8. The moa. What if a bird could grow taller than a basketball hoop? What if it had no wings at all? Not small wings, not useless wings, no wings, completely gone. And what if these giant birds ruled an entire country for millions of years before humans ever arrived? Meet the moa, one of the strangest and largest birds that ever lived. Native to New Zealand, the moa was unlike almost any bird alive today. Some species stood over 3.5 meters tall when stretching their necks. Others weighed more than 200 kilograms. Imagine encountering such a creature while walking through a prehistoric forest. A giant bird towering above you, silently moving between ancient trees. No wings, no flight, no fear. For millions of years, New Zealand existed in extraordinary isolation. Separated from other continents, it became a unique evolutionary laboratory. While mammals dominated most of the world, New Zealand had very few land mammals. No lions, no wolves, no bears, no tigers. In fact, for millions of years, there were almost no large mammalian predators at all. This created a completely different world. Birds became the dominant land animals, and among them, the moa became one of the most successful. But why did it grow so large? Why didn't it fly? The answer lies in evolution. Flight requires enormous energy. In environments with few predators, natural selection often favors larger bodies rather than flight. Over countless generations, moa ancestors gradually lost their ability to fly. Their wings became smaller, then disappeared entirely. At the same time, their bodies grew larger and larger. Without major predators to fear, size became an advantage rather than a liability. The forests of New Zealand became their kingdom. Scientists have identified at least 9 different species of moa. Some were relatively small, others became true giants. Together they occupied many ecological roles. Some fed on leaves, others browsed shrubs and small trees. Some likely shaped entire ecosystems through their feeding habits. In many ways, moas functioned similarly to large herbivorous mammals elsewhere in the world. But if there were no mammalian predators, what hunted them? The answer is almost unbelievable. A giant eagle, known as the Haast's eagle. This enormous bird of prey became the apex predator of New Zealand. Weighing up to 15 kilograms and possessing powerful talons, it was one of the largest eagles ever known. Its primary prey, the moa. Imagine an eagle large enough to attack birds several times its own weight. This predator-prey relationship existed for thousands of years. The ecosystem remained balanced. Then humans arrived. Around 700 years ago, Polynesian settlers reached New Zealand. For the first time, the moa encountered people, and just like the dodo, it had never evolved to fear them. The consequences were devastating. Moa provided enormous amounts of meat. A single large individual could feed many people. Hunting quickly intensified. At the same time, forests were cleared, habitats were destroyed, eggs were collected, nesting sites disappeared, population numbers collapsed. What makes the moa extinction particularly shocking is its speed. The species had survived for millions of years, yet scientists believe many moa species disappeared within only a few centuries after human arrival. Some may have vanished in little more than 100 years. An evolutionary success story that lasted millions of years ended almost instantly, and when the moa disappeared, another species followed, the Haast's eagle. Without its primary food source, the giant eagle could no longer survive. This demonstrates one of the most important lessons in ecology. Species do not exist alone. They are connected. When one disappears, others often follow. The extinction of the moa changed entire ecosystems. Forests changed. Food chains changed. Predators disappeared. Ecological relationships that had existed for thousands of years were broken forever. Today, all that remains are bones. Scientists have discovered remarkably preserved skeletons, eggs, feathers, and even ancient DNA. These discoveries allow researchers to reconstruct what moa looked like and how they lived. Yet one question continues to fascinate scientists. What would New Zealand look like today if moa had survived? Would giant birds still roam its forests? Would Haast's eagles still dominate the skies? Would the ecosystem be completely different? We can only imagine, because the moa now belongs to a lost world. A world where giant birds ruled the land, a world that vanished forever after the arrival of humans. And perhaps that is what makes its story so extraordinary. Not how it lived, but how quickly millions of years of evolution disappeared. 9. The Irish elk. What if one of the largest deer in history carried antlers wider than a small car? What if these antlers stretched nearly 4 meters from tip to tip? And what if a creature so magnificent once roamed across Europe and Asia, only to vanish forever? Meet the Irish elk. Despite its name, it was not exclusively Irish, and surprisingly, it was not actually an elk. Scientists know it as Megaloceros giganteus, meaning giant horn, one of the most spectacular mammals of the Ice Age. Imagine standing on a vast prehistoric grassland. In the distance, a giant figure emerges through the morning mist. At first, you notice the enormous antlers, then the size of the body. This was no ordinary deer. Large males could stand over 2 meters tall at the shoulder and weigh more than 700 kilograms. That is heavier than many modern horses, but it was the antlers that made the Irish elk legendary. Some reached nearly 4 meters across and weighed over 40 kilograms. No living deer has ever evolved antlers on such a scale. The question is obvious. Why? Why would evolution create such enormous structures? Wouldn't they make survival more difficult? Wouldn't they consume huge amounts of energy? Scientists believe the answer lies in sexual selection. Just as peacocks evolved extravagant tails, male Irish elks likely evolved giant antlers to impress females and intimidate rivals. The largest and strongest males may have had greater reproductive success. Generation after generation, antlers became larger and larger and larger until they became some of the biggest biological structures ever carried by a mammal. Yet these antlers were not merely decorations. During mating seasons, males probably fought fierce battles. Antlers collided, rivals pushed against each other. Victories determined who would reproduce. Only the strongest males passed on their genes. For thousands of years, this strategy worked. The Irish elk spread across much of Europe and northern Asia. Its habitat included grasslands, open woodlands, and tundra-like environments. It lived alongside mammoths, woolly rhinoceroses, giant bison, and other Ice Age giants. Life was challenging but stable. Then the climate began to change. Around 12,000 years ago, the last Ice Age ended. Temperatures rose, forests expanded, open grasslands gradually disappeared. This presented a serious problem. The Irish elk had evolved in open environments. Its giant antlers were ideal for displaying strength in wide spaces. But dense forests were different. Navigating between trees became more difficult. Movement became restricted. Food resources also changed. Scientists believe that growing such enormous antlers required large amounts of minerals, especially calcium and phosphorus. Environmental changes may have reduced access to these resources. As habitats transformed, populations became stressed. Some researchers argue that the giant antlers themselves contributed to extinction. Others disagree. Modern studies suggest the antlers were not necessarily a burden during the species' peak. Instead, changing environments likely created conditions the species struggled to adapt to. Then there is another possibility: humans. As human populations expanded across Eurasia, hunting pressure increased. Did humans play a role in the extinction of the Irish elk? Or was climate change already pushing the species toward collapse? Scientists continue to debate this question. Perhaps it was not one factor, perhaps it was many: environmental change, nutritional stress, habitat loss, human hunting. Together, they may have created a perfect storm. Eventually, the great herds disappeared. The giant antlers vanished from the landscape. One of the most extraordinary mammals ever to live became extinct. Today, the Irish elk survives through fossils. Its skeletons are among the most impressive displays found in museums. Visitors often stop in amazement when they see those enormous antlers, because even after thousands of years, they remain difficult to believe. How could an animal carry such weight? How could evolution produce something so extreme? And perhaps the most fascinating question of all, if the Ice Age had never ended, would giant deer still roam across Europe today? Would we share the world with one of the most magnificent mammals evolution ever created? We may never know. But the Irish elk remains a powerful reminder that even the most successful species can disappear when the world around them changes faster than they can adapt. 10. The passenger pigeon. What if I told you that one of the most numerous animals in human history no longer exists? What if a bird so abundant that it could darken the sky for hours, a bird whose flocks contained billions of individuals, could completely disappear within a single century? It sounds impossible. How can something so common become extinct? How can billions become zero? Yet that is exactly what happened to the passenger pigeon, and its story remains one of the most shocking extinction events ever recorded. Imagine standing in North America 300 years ago. You look up at the sky. Suddenly a massive flock approaches, not hundreds of birds, not thousands, not even millions, billions. Historical accounts describe flocks stretching hundreds of kilometers across the sky. Some observers reported that the sun disappeared behind a moving cloud of birds. Others claimed the sound of their wings resembled thunder. For hours, sometimes even days, flocks continued passing overhead. People who witnessed these events struggled to believe what they were seeing. The passenger pigeon may have been the most abundant bird species on Earth. Scientists estimate its population once reached between 3 and 5 billion individuals. Think about that number. At one point, perhaps 1 out of every 4 birds in North America was a passenger pigeon. No modern bird comes close to such abundance. So why were there so many? The answer lies in their lifestyle. Passenger pigeons were highly social. They traveled in enormous flocks. They nested in gigantic colonies. Some nesting sites covered hundreds of square kilometers. Millions of birds could occupy a single breeding area. This strategy provided protection. Predators could never consume enough individuals to threaten the population. The flock itself became a defense mechanism. For thousands of years, this system worked perfectly. Then humans changed everything. As European settlers expanded across North America, forests began disappearing. Trees were cut down. Habitats were fragmented. Breeding grounds shrank. But habitat loss was only part of the problem. Commercial hunting soon became a massive industry. Passenger pigeons were cheap sources of meat. Railroads allowed hunters to transport large quantities to distant markets. Telegraphs allowed hunters to communicate flock locations instantly. For the first time in history, technology gave humans the ability to hunt on an industrial scale. Entire colonies were targeted. Birds were shot, trapped, netted, even killed with smoke and fire. Millions died every year. Yet many people believed extinction was impossible. How could billions of birds disappear? The numbers seemed endless. This assumption would prove fatal. What people failed to understand was that passenger pigeons depended on large populations. Their survival strategy required enormous flocks. As numbers declined, breeding became less effective. Colonies became smaller. Social behaviors broke down. Population growth slowed. The decline accelerated. By the late 1800s, what had once been one of the most abundant birds on Earth had become rare. Then it became extremely rare, and then it vanished. The final known passenger pigeon was named Martha. She lived at the Cincinnati Zoo. On September 1st, 1914, Martha died. With her death, the entire species disappeared. Billions reduced to 1 and then to none. Scientists still view the passenger pigeon's extinction as one of the greatest warnings in conservation history because it shattered a dangerous myth. The myth that abundance guarantees survival. It does not. A species can be common today and gone tomorrow if pressures become great enough. Today, museums preserve specimens of passenger pigeons. Researchers study their DNA. Some scientists even explore whether advanced genetic technologies could someday recreate certain characteristics of the species. But even if science succeeds, one question remains. Could we ever truly bring back the endless flocks that once filled the skies? Could billions of birds once again darken the sun? Probably not, because extinction is more than the loss of an animal. It is the loss of an entire way of life, an entire ecological phenomenon, a living spectacle that future generations will never witness. And perhaps the most chilling part of the story is this: the passenger pigeon did not disappear because it was rare. It disappeared because humans believed it could never disappear. 11. Smilodon. What if one of the most feared predators in history wasn't a tiger at all? What if the animal we often call the saber-toothed tiger never actually belonged to the tiger family? And what if its most famous weapon was also one of the most dangerous risks to its own survival? Meet Smilodon, the most famous saber-toothed predator ever discovered, a creature so iconic that even people who know little about prehistory recognize its enormous teeth. But behind those terrifying fangs lies a far more fascinating story. Imagine standing somewhere in North America around 20,000 years ago. The Ice Age dominates the world. Mammoths move across the horizon. Giant bison graze in vast grasslands. Massive ground sloths wander through forests. Then something begins watching from the shadows. A predator, silent, patient, perfectly built for ambush. This is Smilodon, one of the most successful hunters of its era. The first thing anyone notices is its teeth. Two enormous curved canines extending from its upper jaw. Some reach nearly 30 centimeters in length. No modern predator possesses anything similar. But why? Why would evolution create such extreme weapons? Were they truly useful, or were they a dangerous burden? For more than a century, scientists debated these questions. At first, many researchers imagined Smilodon using its teeth like knives, stabbing prey repeatedly. However, modern studies suggest a different picture. Those giant canines were surprisingly fragile. They could break if used incorrectly. This means Smilodon had to be extremely careful. Unlike lions or wolves, it could not simply bite down with maximum force. Instead, researchers believe Smilodon relied on a unique hunting strategy. First, it used its incredibly muscular forelimbs to overpower prey. Its front legs were among the strongest ever evolved by a cat. Once the victim was pinned to the ground, Smilodon likely delivered a precise killing bite to the throat or neck. The goal was not crushing. The goal was precision. This made Smilodon a specialized predator unlike anything alive today. But what kind of animals did it hunt? The Ice Age was filled with giants: ancient horses, camels, young mammoths, large bison, giant ground sloths. Many of these animals were much larger than modern prey species. Hunting them required tremendous strength. A single mistake could result in serious injury, and injury for a predator often meant death. Yet Smilodon thrived for hundreds of thousands of years. Its fossils have been found across North and South America. This suggests it was remarkably successful. But there is another mystery. Was Smilodon a solitary hunter like a tiger? Or did it live in groups like lions? Scientists still debate this question today. Some of the most important evidence comes from California's famous La Brea tar pits. Thousands of Smilodon fossils have been recovered there. Many skeletons show signs of severe injuries that healed before death. Broken bones, damaged joints, serious wounds. How did injured animals survive long enough to recover? One possibility is social behavior. Perhaps healthy individuals helped injured members. Perhaps they shared food. Perhaps Smilodon hunted cooperatively. If true, this would completely change how we imagine this predator. But the mystery remains unsolved. Then came the end of the Ice Age. Temperatures increased. habitats changed. Many giant herbivores began disappearing. Mammoths declined. Ancient horses vanished from North America. Large prey became increasingly rare. For a highly specialized predator like Smilodon, this created a major problem. Its world was changing. Its preferred prey was disappearing. At the same time, a new competitor was spreading rapidly: humans. Early humans hunted many of the same animals. They altered ecosystems. They introduced new pressures. Scientists continue debating whether climate change, prey loss, human activity, or a combination of all three caused Smilodon's extinction. Most likely, there was no single reason. Instead, multiple factors worked together. Eventually, one of the most successful predators of the Ice Age vanished forever. Today, only fossils remain. Yet those fossils continue to fascinate scientists. Because Smilodon represents something extraordinary. It was not simply a larger version of a modern predator. It was an entirely different solution to hunting, a unique experiment created by evolution, an experiment that lasted hundreds of thousands of years and then disappeared. But perhaps the most intriguing question remains: if Smilodon somehow walked into the modern world today, would it still be an apex predator, or would it discover that even the most powerful hunters can become victims when their world changes faster than they can adapt? As we reach the end of this journey through the lost world of extinct animals, one question continues to echo through history. What happened to all of them? The mammoth, the dodo, the thylacine, the moa, the great auk, the passenger pigeon, the Irish elk, Smilodon. Each species was different. Each lived in a different place. Each faced different challenges, yet all of them share the same ending: extinction. For millions of years, Earth has been changing. Continents moved, oceans expanded and disappeared, mountains rose from the ground, ice ages came and went, entire ecosystems appeared and vanished. For the first time in the history of life, one species has become powerful enough to influence the fate of nearly every other species on the planet: us, humans. We are not merely observers of nature anymore. We are one of the forces shaping it, the rivers that change, the habitats that shrink. All of these decisions leave consequences that may last for centuries. The stories of extinct animals are not simply stories about the past. They are warnings. The mammoth reminds us how climate can transform entire worlds. The dodo reminds us how quickly isolated species can disappear. The passenger pigeon reminds us that even billions of individuals are not safe from extinction. The thylacine reminds us how fear and misunderstanding can destroy a species. The great auk reminds us how greed can erase millions of years of evolution. Again and again, history repeats the same lesson. No species is guaranteed survival. Not the strongest, not the fastest, not the largest, not even the most successful. Survival belongs to those capable of adapting to change. Yet despite everything we have lost, there is still hope. Around the world, scientists, conservationists, researchers, and ordinary people are working to protect endangered species. Some animals once believed to be doomed have recovered. Others have been saved from the edge of extinction. National parks have been established. Protected habitats have expanded. Breeding programs have brought species back from dangerously low populations. These successes prove something important. Extinction is not always inevitable. Sometimes it can be prevented. Sometimes a species can be given a second chance. But time is always limited. Every year, more species move closer to the edge. Some may disappear before most people even learn their names. Others may survive only because someone chose to act before it was too late. Perhaps that is why extinct animals continue to fascinate us. Not because they are gone, but because they force us to think about what still remains. Every living animal on Earth today represents an unbroken chain stretching back through millions of years. Every elephant, every tiger, every whale, every eagle, every wolf, every creature alive today is the result of countless generations that survived impossible challenges, and whether those stories continue depends largely on the choices made in our own time. One day, future generations will look back at this era. They will ask what we knew, they will ask what we saw, and perhaps most importantly, they will ask what we chose to do. Will they inherit a world still filled with extraordinary wildlife? Or will they inherit a world of photographs, fossils, and memories? The answer has not been written yet, because the story of extinction is not over. It is still being written, and for the first time in Earth's history, the pen is in human hands.